students, today we will study how to calculate the electric field due to a long thin wire of uniform charge density lambda. Okay, so we have to study this electric field due to a long thin wire of linear charge density lambda. Okay, now this we have to calculate the electric field due to a wire. Suppose this is a wire on which positive charge is spread over it. Okay, so we have to calculate the electric field due to this thin long wire at a point P, which is at distance R from the thin wire. Okay, now for this, if we use the formula of Gauss theorem, so by Gauss theorem it is very easy to solve it. So if you have to calculate the electric field by Gauss theorem, means by using Gauss theorem, if you have to calculate the field using Gauss theorem, if we have to calculate the electric field, so we have to assume a cylinder. This is a cylinder, this is the Gaussian surface. Suppose this point P is here, so this is a Gaussian surface around the wire. Now this is surface, suppose this is surface S1, this is curved surface which is S2, and this is again a circular surface which is S3. So you know that by Gauss theorem, if you have to calculate the electric field, then we have to use the formula phi is equal to E dot ds. Now this formula we have to use. Okay, so these are three surfaces. So three surfaces, so electric field would be in this direction. The electric field would be in this direction. This is the direction of electric field. Here also, the electric field would be in this direction. Horizontal electric field will be there. Okay, so this is surface S1, this is surface S2, this is surface S3. If we can see the area vector of surface S1, so this will be perpendicular. The area vector is always perpendicular to surface. So this ds1 will be perpendicular to the E. Here also, this is surface S3, the electric field, the area vector would be perpendicular to the surface. This is ds3 and this is electric field. And in this surface, this is the curved surface, the electric field would be in this direction and the area vector would also be in this direction. This is ds2. Now this is area. Now if we divide the flux into three surfaces, this is S1, this is S2, this is S3. So total flux would be phi is equal to phi 1 plus phi 2 plus phi 3. Now these are three flux according to three surfaces. Now phi 1 is this flux through S1. So this will be E dot ds 1. This is closed integral. Now this is phi 2. Phi 2 is the electric field due to this surface S2. This will be phi E dot ds2. This is surface S1. Suppose this is 1, this is 2, and this is third one is E dot ds3 surface 3. Okay. Now surface 1, you know that this is surface 1, this is surface 3. The electric field is perpendicular to the area vector. Here also the electric field is perpendicular to area vector. Here both are perpendicular here. So by surface 1, so this would be equal to phi would be equal to E dot ds is E dot ds eds cos 90. It will be E dot eds1 cos 90. This is surface 1 and this is surface 2. eds2 will remain same. E dot ds eds2 cos 0 degree, because here the surface 2 is along the area vector is along the electric field. So the angle is 0. So this will be eds2 cos 0, and this is surface 3 where the electric field is normal to the area vector. So this will be eds cos 90. Now we know that the value of cos 90 is 0. So this will become 0, this will become 0. So both will become 0, 0 plus. This is E ds2. So electric field is constant at distance r. So we can write this E integration ds2, and cos 0 is 1, and this is again this E dot ds cos 90 is 0. Okay, so this flux comes out to be E into integration of ds2. Now integration of, this is the curved surface. The curved surface of cylinder, the area of curved surface of cylinder is, now suppose that the height of this cylinder is h. The height of this cylinder is h. Okay, so and the radius of this cylinder, now this is the distance r, which is the radius of the cylinder also. So it would be equal to E into the curved surface area is 2 pi r h. Now this is the area of curved surface. Now this flux phi would be equal to E into 2 pi r h. Now by Gauss theorem, we know that this phi is total charge upon epsilon naught. Total charge equals epsilon naught. Now we know that this is having linear charge density lambda, and this is spread over distance h. So this q can be written as lambda into h upon epsilon naught. So in place of phi, we can write lambda h upon epsilon naught. So it will be lambda h upon epsilon naught, which is equal to E into 2 pi r h. So this h get cancelled. So electric field comes out to be lambda upon 2 pi epsilon naught r. So this is the electric field due to state conductor. Pause. Now if we have to calculate the electric field due to long thin wire of uniform charge density lambda without Gauss theorem, without using Gauss theorem, then how we can calculate? Now suppose that this is a long wire, straight long wire. Now this is having positive charge is here, and this is the origin O at distance y. We have to calculate the electric field due to this wire. Now suppose that this is origin. Now at x distance, if we consider a small element of charge, this is of length dx having charge dq. Now the electric field due to dq at distance at point P would be in this direction. This dE would be in this direction. Suppose this is angle theta. Now if we take symmetry, at x distance left of this also, there would be another charge equivalent to q, equivalent to dq, which will be acting in this direction. So by symmetry, if this is angle theta, this would be also angle theta. So this would be angle theta, and this is also theta. So if we divide the component, it will be dE sin theta, and it will be dE cos theta, and here is also, this is dE sin theta, and this will be dE cos theta. Now you can see that this d sin theta both are horizontal and equal and opposite, so they will cancel out. Only dE sin theta will be remain. So the direction of electric field would be in this direction, always upward. Okay, so net electric field would be dE is equal to dE cos theta, which we have to integrate. Okay. Now this dE is due to charge dq. Now this is distance x, this is distance y. So by Pythagoras theorem, it will be x square plus y square. So this dE would be equal to 1 upon 4 pi epsilon naught dq upon x square plus y square. Okay, this is under root. So if we square it, this will become x square plus y square cos theta. Now this we have to integrate. Now here the dq we can convert, this is having linear charge in lambda, so we can put this dq as lambda into dx. So if you put it here, this will be dE is equal to 1 upon 4 pi epsilon naught lambda dx upon x square plus y square into cos theta. Okay. Now if we see this triangle, if we take tan theta, then tan theta would be equal to perpendicular x upon y, x by y, and this would be equal to x is equal to y tan theta. If we differentiate this, then this will be dx is equal to y sec square theta d theta. Okay. Now if we put the value of dx here, so it will be the value of x and dx here, so it will be de is equal to 1 upon 4 pi epsilon naught lambda dx. Now in place of dx we write this y sec square theta d theta upon x square. Now x is y tan theta, so this is y square. If we take common, this will be 1 plus tan square theta. Now this is sec square theta, this is 1 plus tan square theta. Now this can be written as lambda y. Now this y and y get cancelled, so here it will be lambda sec square theta d theta upon, now this is cos theta is also here, so this is cos theta will remain here, so this is cos theta, and this is y sec square theta. Okay, so this sec square theta, this gets cancelled, so this will become, now this is 1 upon 4 pi epsilon naught also, this is 1 upon 4 pi epsilon naught, so it will be de would be equal to lambda upon 4 pi epsilon naught. Now this is lambda by y integration of cos theta and d theta. Now you know that this theta, if this rod is of infinite length, then theta would vary from minus pi by 2 to plus pi by 2. Okay, so the theta is varying from minus pi by 2 to plus pi by 2. So if we calculate this, this will become 1 upon 4 pi epsilon naught lambda by y integration of cos theta is sin theta. Now the limit of this is minus pi by 2 to plus pi by 2. Now after solving this, this de will become e. It will be 1 upon 4 pi epsilon naught lambda by y. Now this is upper limit minus lower limit. This is sin pi by 2 minus sin pi by 2. So this will become lambda upon 4 pi epsilon naught y. This is 1 minus 1. So this will become lambda 2 lambda upon 4 pi epsilon naught y. Now if you divide 2 with 2, this will become E is equal to lambda upon 2 pi epsilon naught y. Now this is the required electric field of long thin wire without using Gauss theorem.